All right, welcome. It's going to be my second attempt at explaining how to do scale factor for a map. So you have an actual area. Right here would be 14,000 or 146,000 feet, 86,000 feet. And you need to scale it down to a sheet of paper that's 24 by 36. So orientation, you would check to see the orientation. So there's a limit. If it's shaped like this, right, when it's all said and done, the limit would be your 36 direction. So you need to scale it this direction first. So probably the first step you need to do, and you can't really tell on this one because that's not the actual dimensions of the thing. So obviously you can see that this is bigger, maybe it's a little longer than this, but you can't tell unless you check it mathematically. So if you divide 36 by 24, you can see it's at 1.5. So there's 1.5 in width to the 1 in height. So 2 to 1 would be out here. So 2, obviously, if you divided and you had 2, it would be wider. So if it was less than 1.5, it would be taller. The limit would be the 24 to a point where you might even decide to rotate it. So how you do that, let's just get to it. We're looking at 146,880 divided by 86,400. And that gives us 1.7. So it's wider, right? The ratio, it would be sticking out here a little bit. So we need to limit in the 36-inch direction. So the one we're going to work with is this one. So we need to get 102. Let's go to calculator. We'll have 146,880, and that's in feet. So we're going to multiply it by, we need to get down to inches. So we're going to multiply it by 12. And it's not squared because we're only going in one direction. We're not scaling an area in both directions. So times 12, that's from feet to inches. And then we're going to divide it by the scale factor divided by, we don't know the scale factor, so that's going to call it x. So we're going from the larger number down to a smaller number. So we're going to divide it equals, and our limiting factor there is 36. This is not including the borders. So that's the formula that we would use, Control C, Control V, the equation that we would use, and then we need to solve for x. So divided by 36, and that's pretty much it, compute. And that will give us Control V equals, we're just going to Control C, V, just show you the steps, Control R. And I'm doing this step in case you're not familiar with the program. I'm just talking aloud. I've been doing some training videos on this program. So the scale factor is 48,000. So if we did it exactly there, we'd end up here. But if we scaled it down a bigger number, it would get even smaller. Like if it was 1,000,000 to 1, it would be down this tiny, right? So we can increase to an even number. We don't want to have an odd number like that. So we're going to say 50,000. So the closest is 50,000. So what we're going to do is we're going to go 14, same thing. Now we're going to actually do the scale to find out how big it is on the sheet. And we're going to, interesting, got an extra remnant in there. Equals, so now we're going to change it to 50,000. And we're going to solve for x. So that's how it goes, right? Compute, Control C, let's copy that first, compute. Control V equals, we don't need that remnant out there. Control C, let's put it down here, Control V. So our final solution is 35 points. So would have been 36, but we increase the scale factor a little bit to get to an even number. And then we're going to do the same thing except for right here, we're going to use this number, 86,400. And that's going to be delete. Control C, compute, Control V equals Control C, Control V. So that's what we have in the other direction. So now we can do is a rectangle, 35 point, 25, tab 20.736, enter. And that's how that would fit on the page. All right, and now you have scale factor. So 1 here to 50, 1, 2, 3. That's our scale. Let's change that to capital letters. All right. And then here it would be actually the opposite. You'd have T scale equals 50 to 1. Right? If you wanted to say, hey, let's say this was so small I couldn't see it, and I needed to make it bigger, and you were working with the bigger one to reduce it, it would be 50,001. Over here it's 1 unit here to 50,000 units in real life. And that's how you scale that up. So we could do the area. Let me just show you the area. Let's say they're giving you the area, and this is actually to scale, right? So let's check and make sure. Yeah, of course. I think so. Text 1, just to get rid of the multiplier. Close. Yeah, 36 inches. And let's do this. Let's go, just click right on there. If you multiplied the 2 dimensions here, you'd end up with 730.94. So Control C. Let's go to right here. Now scale it up. Let's say we know the scale, we know the size here, but we don't really know what it is in true life. So we could, we're going to do that. So Control V. Here's our scale. That's square inches, so it's inches squared. So let's go like this: T, Control V, Control. We got inches, all right, and then T. I don't like that. Inches, and then we have T2, enter, so inches squared. So now when we do our formula, we already know that that's the area that's squared. And then we don't do anything with that. We just leave it. We don't square it or square root it or anything. So we need to find out what it is in true size. So we're going to multiply it by 50,000. So we're just dealing with the area. So it's 50,000 in both directions. So it's squared times so this times 50,000 actually divided by 12 squared, because now we're going to go to from inches to feet. So we have the true inches. Now we're going to convert it to feet area, and then divide it again by 5,280 squared, because that's feet of miles in both directions. And that's it, I think. Yeah. Control C, compute, Control V equals, let's double check that, 730 inches squared, right? Times 50,000 squared divided by 12 squared divided by 5,280 squared. Yeah, we end up with 455 miles squared. Control C, Control V, and T Control V, backspace, inches, miles, enter, delete, T2, enter. So that's it. So now we should, if we do this, 146,880 times 86,400, and then hit compute, you get the square feet divided by 5,280 squared equals, should give us the same number, right? 455.20. Yeah, we're starting to get a little decimal place there, but that's how you do that. So that's showing you that the scale factor 50,000 to 1 at this dimension is actually true. And I think I shouldn't put those in there, but that would be like this. So then scaling these two numbers up to multiplying by each other, you end up with this. And then I did some rounding, but then this area is squared, so you don't have to do any of the lengths and widths. You just get the area, put it in that formula there. Did I put it in? Did I show it? Let's do it again. 730. I think I didn't copy it down. 730.94. So that's we're going to go from inches to scale factor times 50. 1, 2, 3. Now we're in inches, true. So divided by 12 squared. Oh, I got to do 50,000 squared. 12 squared divided by 5,280 squared. That's our equation. Control C, hit that. Control V equals. Control C, Control V, and that was just to check. Control R, and that, I think we came out with something that was really close. But that's how you do it. Hope that helps you. If that helps you, maybe pass that along to somebody else that's struggling, or share it to somebody in your class or in your cubicle area or in the field. Hopefully you're in the field, man. I love it in the field. I love this stuff, but not enough to work in an office. Maybe one day I'll have to go back. Catch you later.